The way that Code First works, by default, will probably work for most applications early in their development cycle. But when you're ready to deploy the application to a production server, or need more flexibility in how Entity Framework creates a database, you can take advantage of data annotations on the model classes, or use a Fluent API to take control of the process. And even if you have an existing database that the application will use, you can still use Code First Design and map the POCOs to the existing tables and fields. The biggest benefit of using Code First Design is that it lets you focus on domain-centric modeling for application development, focusing on the data objects in your application rather than on the database or even the entity data model. In fact, your application won't even have a model and won't have an .edmx file in the project or any XML mapping code. Entity Framework takes care of inferring the model, including the conceptual, storage, and mapping models, at runtime. It really is a code-centric style of writing database applications. There are two different ways that you can use Code First for development. The first, and what I expect will turn out to be the most common way, is to write data model.NET classes in your application first, then let Code First in Entity Framework create the database for you. And this is the usage scenario that I'm going to explore in this course. Using Code First this way is the easiest, most agile way to jumpstart database development and let you evolve and refactor the application in its early stages right through to production. Code First can even update the database as you make changes to the model. The other usage scenario is to again create the data model classes in your application, then map those data classes to an existing database. This will provide the information Entity Framework needs to provide data access between the application and the database, without the formality of an entity data model. This might sound a little like database first design, but the difference is that you create your own POCOs rather than having Entity Framework generate them from the entity data model, without a lot of the overhead of the wizard-generated model. Both of these usage scenarios have two ways in Entity Framework to map classes to objects in a database. One uses annotations on the classes and properties of the data model classes, and the other uses the DB Model Builder API to control the mapping in code. And these are quite different techniques, but you can also mix and match the two techniques together. The nice thing is that Visual Studio comes with everything you need to build Code First applications. Although Entity Framework is an out-of-band product that you need to keep updated using NuGet. Now you'll learn how to build an application using Code First that uses its features for building the back-end database. The key to building a Code First design is to create model classes for the application, and those classes don't derive from any base class or implement any interfaces. They really are just clean .NET code. The properties are all standard .NET data types. Nothing about them indicates anything about where the data is persisted. This really is a powerful feature of Code First design because it lets you create your own classes that are not tied to a specific database or data access API at all. This lets you focus on the domain of the business needs of the application without being concerned about the persistence implementation. It also provides the flexibility to change database implementations in the future without rewriting your model or data access code. Now that's not to sugarcoat that scenario. You'll still probably have some work because it's a pretty rare application that doesn't take advantage of data store specific features, but at least you won't have to change your model classes. And then you also may have to migrate data, but that's a database issue, not something that has anything to do with the application directly. Okay, so the application that I'm going to build here is a very simple ordering system for customers. The data model is going to consist of three classes: customer, address, and order, from which Code First is going to create the corresponding tables as well as a join table for many-to-many relationship. And you can start to see just how slick Code First is. In this exercise, I'm going to create a basic MVC web application, as well as the POCOs, the plain old CLR objects, in order to implement a model. That'll provide the framework for using Entity Framework with the objects for data access. So here I am in Visual Studio. I'll go up to File, New Project, and I'm going to create a C# web application. And I'll name the project Ordering. And I'll put it in a convenient location, click on OK, and as usual I get the new ASP.NET project. So I'm going to once again select the empty template because I don't want all the overhead of sample code and so forth. But it's going to be an MVC application, so I'll add the folders and the core references for that kind of web application. And otherwise I'll leave all of the defaults the same. Now, before I do anything else, I want to add the newest version of Entity Framework. So I'll go into the Package Manager console, let that start up, and I'll do Install, Package, hit Tab, and Entity Framework. This is pretty much always necessary because even though a lot of the project templates in Visual Studio include Entity Framework, this makes sure that I'm working with the latest and greatest. And you can also use NuGet in order to install previous versions as well, at least some previous versions. So if you're dependent on an older version of Entity Framework, you can install that as well by including the version number. And that's a slightly different syntax within the Package Manager console. And as you can see, it installed version 6.1.2. I can come up here to Solution Explorer, look at References, and see that I now have the Entity Framework and the Entity Framework.SQL Server namespaces. Alright, so now it's time to start creating the model. I'll come over here to Solution Explorer, collapse References, and right-click on Models, and I'm going to add a class. So I could use New Item, and that will give me a list of options for this particular context, a C# type of application. But because a model is just a class, I can just use this option right there. Click on that, and I'm going to name this Ordering Model. So that's going to be the name of the file. Click on Add, and it opens that up within the designer. Now I don't actually want an Ordering Model class. Instead, I'm going to create a class for Customer, Address, and Order, a very rudimentary ordering kind of system. You don't have to have a class that is the same name as the file. This just happens to be the model for the ordering application, which is why I gave it that name. Alright, so I'll start out by creating the Customer class. And I'm going to have some basic information here, so I'm going to do public. They all need to be public so they're accessible. I'll include a primary key called Customer ID and make that an automatic property. Okay, for later use I'm going to go ahead and copy that, just make it a little bit easier. And then I'll add a few more fields that would be typical kind of information that you'd want about a customer. So a public string for the first name, and I'll paste in my getter and setter. Public string for last name, for company, for email address, phone, and a public date time for created, to record when this customer record was created. Okay, so that's the basic information that I'm going to include within this customer class. Obviously, in a real application, you would have a lot of other things. Okay, so those are the scalar properties. Those hold pieces of information. I'll come back after I create the other two classes for this model and add some navigation properties as well. So now I want to add the address class. So this is going to be a public class called address. And I'll add a primary key, make that an int again. And then some basic address information. So a street address, city of course, state, province, and one for the postal code. Okay, so that's my basic address class. And then the final class that I need to create is the order class. Add a new primary key. A date time variable for the order date. Another one for the ship date. And then again for this very simple kind of application, a decimal for the total order. I'm not going to complicate things and have order items and things like that, line items, classes like that. Just going to keep it very simple here. Okay, so there are my three classes that I'm going to use for this simple application. Now, one of the first things to notice is that there's nothing in this code that indicates that I'm going to use Entity Framework with it. That's one of the nice things about the design of Code First, is that I don't have to include anything here to work with Entity Framework. Now, I can include data annotations, and I can include Entity Framework code if I so choose. But even the data annotations aren't specific to Entity Framework. Entity Framework will use them if they're there, but I don't need to include them to make Code First work with these classes. All right, now the next thing I need to do is include navigation classes. I need to define the relationships between these different classes. Now, even this is not specific to Entity Framework, but Entity Framework will see these relationship properties, these navigation properties, and be able to make use of them when creating the database, as well as to link together the different objects. All right, so now that I have all three classes created, I can add the navigation properties. So a customer is going to have one or more addresses and one or more orders. So I'm going to create a couple more public classes. This is virtual, and I'll talk more about why I'm making that virtual a little bit. I'm going to make this an iCollection because it's going to be a collection of addresses, and it's based on the address object. And I'll name it addresses. And I'll include the getter and setter. And then I'll include a second one for the orders that are associated with this customer. iCollection again, and this is based on order, and I'll call it orders. All right, so those are the two navigation properties that I need for the customer class. Okay, I also need to add one to the address class because a single address is going to be related to a customer. So this will be public as well, virtual. And this is going to link to the customer, and I'll call it customers. So now you can see how you can implement kinds of relationships between the classes. In this case, an address can have multiple customers, and a customer can have multiple addresses, because I created a collection object there, a collection object there. So this scenario is where I can have a single address in my database, and it can be used by multiple customers, husband, wife, kids, grandparents, all who live in the same house. Okay, so this is how you would model a many-to-many relationship. Okay, collection here and a collection there. Okay, that's all I need for the address object. So now I need to add a couple of navigation properties to the order class. So the first one I need to include is that each order is associated with a single customer. So I'll create another public virtual class, but this time rather than using a collection object, I'm just going to use the customer object directly, a single version of it. And I'll call it customer. And so that's how you model a one-to-many relationship. So I have one customer associated with this order, but I can have multiple orders associated with a single customer. So you can start to see how you have a lot of flexibility to define the relationships between these different objects. Okay, then I also need another navigation property because I need to identify the ship to address. So I'll add another public virtual. Again, this is a single object, so it's going to be address. I'm going to call it ship to address because that's going to identify it. I could just use address, but if somebody is looking at the definition of this class, they don't know if it's a ship to address, a bill to address, which I could also include by including a second relationship to the address object. Okay, now I mentioned that I made all of my navigation properties virtual. The reason I did that is, well, I had to do that. And the reason is that I wanted to enable lazy loading as well as change tracking on the entities. So what the virtual keyword does is it allows Entity Framework to create proxies in order to support those particular features. Okay? So if I don't need those features, I don't need to make it virtual. Okay, another thing about the navigation properties is that when I include a navigation property with a multiplicity of 1, such as the customer and address properties in this code for the order class, I might also want to include a scalar property for the foreign key value. So if you follow the pattern of naming the foreign key fields with a parent class name followed by ID, Code First will recognize them as foreign keys automatically. So it's another convention over configuration. All right, so for the order class, I might include the customer ID and address ID fields of type int. And this really has two benefits. First, it lets you access the foreign key value directly when you need to, because sometimes you need access to that in code. If you don't, Entity Framework will handle all that behind the scenes for you. Second, if you don't include these fields, the foreign key fields in the database will be named something like customer underscore customer ID and ship to address underscore address ID, which are a bit unwieldy. Okay, so I'm going to go ahead and add both of those fields. So I'll put in a public int customer ID and a public int for address ID. Okay, so once again, I have three classes now. I have some navigation properties, I have some scalar properties. Nothing yells Entity Framework at all. Now what I need to do is add a context class that is something that Entity Framework needs. It's code that you wouldn't otherwise need within an application. But I need to define the context object, which is the top-level object that gives me via code entree or entrance into this model. All right, so I'll put it down here. And actually, before I do that, I'm going to be using some Entity Framework specific objects, so I need to add a using statement. So all of those objects are in the using system.data.entity. Because specifically, I'm going to be accessing the DB context object and the DB set collection object. Okay, so now I can create that context object. It needs to be a public class, and I'm going to call it ordering context. This is another naming convention that you can opt to use or not use as you care. But this is the name of the model and specifically the context. So I have ordering model in the code file, ordering model. and I have the different customer address and order classes, which makes up the model, and then I have the ordering context. And I need to inherit from DB context. So that's the object that gives it all of its Entity Framework powers. All the magical powers of the features that Entity Framework is now going to bestow upon this application. And here, I need to add a reference to a collection of all of the objects that I want to include in the model. So they need to be public, and then I'm going to use that DB set collection object. And the first one is going to be of type customer, and I'll call that customers, and include the getter and setter. And I need to do the same thing for address. I'll call that addresses. And one for order. Helps to use the right syntax. Okay, there we go. So again, this is what ties this model together. I'm going to be using ordering class within my code in order to get a reference to the data model, and then I can access the customers collection, the addresses collection, the orders collection, and Entity Framework will have behind the scenes wired up the relationships between those, and I have access to the properties, and it'll take care of loading the data from the database and then persisting it to the database when I make changes to the values of the properties of the objects, and then want to persist it back to the backend database. All right, now, just real briefly about this DB context object. This is a simplified version of the main object context class in the Entity Framework. Object context was the only option available in earlier versions of Entity Framework, but when Microsoft came out with Code First, they needed a simplified form just to make this code a lot more streamlined. We'd have to do a lot of different other kind of messy things with the object context object if we tried to do the same sorts of things here. All right, so what Microsoft did is they optimized the DB context for common tasks and coding patterns. And even though they call it a lightweight object, it really is very functional and provides access to all of the Entity Framework features that you're likely to need in an application. And as we look forward to what Microsoft has talked about with newer releases of Entity Framework, DB context really is the future of Entity Framework. This is the object that we're going to be using all the time and never falling back to object context for the most part. It's going to be, object context is going to remain behind the scenes, but it looks like it's going to essentially recede into an object that Microsoft just makes available to provide the features of Entity Framework, but the public surface of Entity Framework is going to be DB context. So it's an object that you'd be wise to get to know pretty well. Okay, so that's the ordering model. Now there's one more thing that we need to do to really wire this up correctly. By default, Code First creates a SQL Express database if that edition of SQL Server is installed on this development machine. Otherwise, again by default, it creates a local DB version of the database. Okay, so in this case, I don't have SQL Express installed, and unfortunately some versions are out of sync just with the way Microsoft does Visual Studio and so forth. The version of local DB that's installed with Visual Studio 2013 is based on SQL Server 2012. But on this machine, I have SQL Server 2014 installed. And MVC will create and use the local DB database, but the tooling within Visual Studio is broken. So this is just one of those cases where the SQL Server team has released a new version. Visual Studio 2013 came out before that, and so it doesn't understand about SQL Server 2014, so it's using a different version of local DB. So it works within the application. I could go ahead and do that. It'll create the local DB database just fine. But I wouldn't be able to access the database using, say, the Server Explorer within Visual Studio. And so what I'm going to do instead is instead of installing SQL Express or work around the IDE issues, and apparently there are some workarounds for the version conflict with LocalDB, I'm just going to tell CodeFirst to create the database in the full instance of SQL Server that I have installed. So in order to do that, I have to come over to the web.config file. This was created when I created the, quote, empty MVC application. And I need to add a connection string. But the important thing here is that in order to make CodeFirst use this connection string instead of what it would do as the default, again, look for SQL Express, couldn't do that, do LocalDB, the name of the connection string has to be the same name as the Entity Framework context object. Okay, so I'm going to come down here immediately after config sections and add a connection strings section. So I'm going to use the add element, and I'll give it a name, and recall that the name of my context object is ordering context. So I need to name the connection string that same name. And then I can define the connection string. So this is a typical ADO.NET connection string, so I need to specify the data source, and that's going to be localhost, because I want to run against my local machine. The initial catalog, just another word for database, is going to be ordering.models.ordering context. Okay, so kind of a strange name for a database. But the reason I'm doing this, there's really two reasons that I'm doing this. One is that is the default name of the SQL Express database that I would get if I wasn't doing this, if I wasn't redirecting it to use the full instance of SQL Server 2014. If I accepted the default of using SQL Express or LocalDB. That's the name of the database that I would get in SQL Express or LocalDB. Okay, and then the second reason is that later on I want to use the same application to show how you can make changes to the name of the database as you use CodeFirst to update the database and the schema. Okay? All right, so the initial database is going to be called orderingcontext.models.orderingcontext. Okay, I'll finish out the connection string. I'm going to specify integrated security. If I can spell right, is set equal to true. So that's the end of my connection string as such. I also need to specify the provider name, and that's system.data.SQL client. Okay, and there's my connection string. So I'll just add a couple of line breaks here to make it a little bit easier to see the whole thing. Can't quite see the full connection string, but if you've created any connection strings in Visual Studio using the dialog box, same sort of thing that you would do. Okay, but again, the crucial thing here, besides a valid connection string to a valid data source, is that it needs to be named the same as the ordering context object that I defined here for my model. Now, that should suggest to you too that I can have multiple models in a single application, I can have multiple context objects, and I can have multiple connection strings with different names, and then each of those models will hit a different data store or connect to the same data store using different credentials or different properties of the connection string. So I have a lot of options in how I use different data stores within an application. Okay, I'll save all my work. So that's it. I'm done as far as defining the model. That's all the code that I need to write to implement the CodeFirst model and implement data access for the application. Using the ordering context class, Entity Framework takes it from there and will create the database and model and provide all the runtime support for data access, just like in database first and model first applications. It really is pretty amazing. And this last step of adding a connection string really was something optional. I just did it because I wanted to redirect and use a different data source than what Code First was doing as the default.